Welcome to GFunFacts Online. Today we're talking about something you've probably looked at hundreds, if not thousands of times. The world map. Whether it's on your phone, in a classroom, or in a news report, it seems like a simple, factual representation of our planet. But what if I told you that the map you see most often is lying to you? That it's a funhouse mirror, systematically distorting the world, shrinking entire continents while inflating others, and, in the process, shaping your perception of power, importance, and reality itself. This isn't a conspiracy theory. It's a cartographic controversy that's been raging for centuries. At the heart of it is a simple, impossible geometric problem. Imagine trying to flatten an orange peel. You can't do it without tearing or stretching it. The same is true for our spherical Earth. It's mathematically impossible to represent its surface on a flat plane without distortion. Every single map projection is a compromise, a set of rules that chooses to sacrifice one quality to preserve another. Cartographers have four main properties to play with: shape, area, distance, and direction. A map that preserves the correct shape of countries is called conformal. A map that preserves the correct relative size or area of countries is called equal area. And here's the crucial trade-off. A map cannot be both. You can have the right shapes, or you can have the right sizes, but you can't have both. This single technical limitation is the seed of a debate with profound political consequences. To understand just how revolutionary our modern maps were, we have to look at what came before. In medieval Europe, maps were less about geography and more about theology. The most common format was the TO map. Imagine a circle, the O, representing the ocean encircling the known world. Inside it, a T is formed by the Mediterranean Sea and major rivers, dividing the land into three continents: Asia, Europe, and Africa. Asia was placed at the top, in the east, the Orient, home of the rising sun and the biblical Garden of Eden. Jerusalem was placed at the dead center, signifying its spiritual importance. These weren't tools for navigation, they were visual guides to a divinely ordered world. The big shift came during the Renaissance, with the rediscovery of the work of Claudius Ptolemy, a Greco-Roman scholar from the 2nd century. His treatise, Geographia, reintroduced a scientific, mathematical approach to map-making. Ptolemy pioneered the use of longitude and latitude and developed projections to translate the curved Earth onto a flat plane. His work laid the foundation for the next great era of cartography. That brings us to 1569. The Flemish cartographer Gerardus Mercator publishes a massive world map with a very long title, which translates to a new and more complete representation of the terrestrial globe properly adapted for use in navigation. This was a map for a new age. The age of discovery was in full swing, and sailors faced a major problem. On a globe, a course of a constant compass bearing, called a rhumb line, is a spiral. To follow it, you'd have to constantly adjust your heading, which was difficult and led to disastrous errors on long voyages. Mercator devised a brilliant solution. He created a conformal map, one that preserves local angles and shapes. He projected the globe onto a cylinder, but with a mathematical twist. He spaced the horizontal lines of latitude further and further apart as they moved away from the equator. This stretching had a revolutionary effect. On a Mercator map, any rhumb line becomes a perfectly straight line. A sailor could now simply draw a straight line from Lisbon to the Caribbean, follow that single compass bearing, and arrive safely. It was an incredible tool, custom-built for navigators. But this navigational genius came at a huge cost: the severe distortion of area. To keep the shapes correct, the land masses near the poles had to be stretched vertically and horizontally. This dramatically inflates their size. On a Mercator map, Greenland looks about the same size as Africa. In reality, Africa is 14 times larger. Europe appears bigger than South America, even though South America is almost twice its size. Alaska looks as big as Brazil, but Brazil is nearly 5 times bigger. Mercator knew this. His map was explicitly for the use of sailors. The problem started when this specialized tool was pulled from its context. By the 18th and 19th centuries, the Mercator projection wasn't just for sailors anymore. It became the default map for atlases, encyclopedias, and most importantly, for the walls of classrooms all over the world. This happened to coincide with the peak of European colonialism. The map, with its exaggerated northern hemisphere, became a silent but powerful piece of imperial propaganda. By visually enlarging Europe and North America, the Mercator projection reinforced a Eurocentric worldview. It made the colonial powers in the north appear physically larger, more dominant and more significant than the colonized nations in the global south, which were mostly near the equator and thus visually diminished. Size, on a map, is subconsciously equated with power. During the Cold War, this cartographic propaganda continued. Western maps would often show the Soviet Union in a menacing red, its size exaggerated by the Mercator projection, creating a visual sense of an overwhelming threat. The map was a weapon, shaping public opinion without saying a word. This widespread misuse didn't go unnoticed. The most famous challenge came in the 1970s from a German journalist named Arno Peters. In 1973, he held a press conference to denounce the Mercator projection as racist and colonialist, arguing it deliberately belittled the developing world. He presented his own map, the Peters projection, as a superior, area-correct alternative. On his map, all countries were shown at their true relative size. Africa and South America looked vast and prominent, while Europe and North America were compressed. Peters' passionate critique resonated with aid organizations and social justice groups who saw the map as a tool for promoting global equality. It became a symbol of a more just worldview, famously even getting its own segment on the TV show The West Wing. However, the story isn't that simple. The professional cartographic community was quick to point out that Peters hadn't actually invented his projection. It was mathematically identical to one presented in 1855 by a Scottish clergyman named James Gall, so it's more accurately called the Gall-Peters projection. Critics also noted that while it preserved area, it severely distorted the shapes of continents, making them look oddly elongated and squashed. One cartographer famously quipped they looked like wet, ragged, long winter underwear hung out to dry. Despite the controversy, Gall-Peters successfully dragged the issue of map distortion into the public spotlight. The debate sparked a search for better alternatives, for compromise projections that offer a more balanced view of the world. One of the most successful was the Robinson projection, created in 1963. American cartographer Arthur Robinson was asked by the publisher Rand McNally to create a map that simply looked right. The result was a projection with curved meridians that gives a more spherical appearance, minimizing the most glaring errors of both shape and area. For decades, it was the preferred map of the National Geographic Society. In 1998, National Geographic switched again, this time to the Winkel Tripel projection. Developed in 1921, its name Tripel refers to its goal of minimizing three kinds of distortion: area, direction, and distance. It's a compromise that doesn't perfectly preserve any single property, but has one of the lowest overall distortion levels. It has a pleasing aesthetic and is now considered a new standard for general-purpose maps. More recently, we've seen even more radical innovations, like the AuthaGraph projection, invented by Japanese architect Hajime Narukawa in 1999. This complex design divides the globe into 96 triangles, transfers them to a tetrahedron, and then unfolds it into a rectangle. The result is a map that preserves the relative areas of continents and oceans with incredible fidelity, while keeping shape distortion to a minimum. It's so well regarded that in 2024, the state of Nebraska passed a law requiring public schools to use maps based on either the Gall-Peters or the AuthaGraph. So with all these better alternatives, you might assume the Mercator projection is a relic of the past. But you'd be wrong. In the digital age, it's had a surprising comeback. The default flat map used by Google Maps, Bing Maps, and nearly every major online provider is a variant called the Web Mercator. The reason is purely technical. The Mercator's straight, perpendicular grid makes the math for a seamless, zoomable, tile-based map system much simpler and faster. When Google Maps launched, this computational efficiency was critical. Also, when you zoom in on a city or a street, the Mercator's conformal property is a huge advantage. It preserves local shapes, so roads and buildings look correct. Since most of us use these maps at a local level, the massive distortions at the global scale were deemed a necessary trade-off for performance. The consequence is that billions of people are still being presented with a Mercator-based view of the world every single day. To their credit, Google and others have tried to address this. If you zoom all the way out on Google Maps today, it will switch from the flat Mercator map to an interactive 3D globe, giving you a truly accurate perspective. And popular websites like The True Size Of allow you to drag countries around to see just how dramatic the Mercator distortion really is. Ultimately, this isn't just about lines on a screen. It's about the map we build inside our minds. Psychological studies show that the visual representations we are exposed to directly influence how we perceive and remember spatial information. When we consistently see a map that enlarges the global north and shrinks the global south, it subtly embeds geopolitical biases into our thinking. The story of map projections, from the theological TO maps to the digital age, reveals that maps are never neutral. They are artifacts of their time, reflecting the science, technology, and political ideologies of their creators. The Mercator projection, a brilliant solution for its era, became a source of persistent, unintended bias. The efforts to correct this, from the political crusade of Peters to the elegant compromises of Winkel Tripel, show a growing awareness of the power maps hold over us. The future may offer new solutions. Digital globes on our phones are a great start, but the real game changer might be augmented reality. AR mapping overlays information directly onto our view of the real world, promising a future where navigation is no longer about interpreting a 2D symbol, but about following intuitive cues in our physical environment. The quest for the perfect flat map is impossible, but the struggle to create better, more honest ones is a vital endeavor in shaping a more accurate and equitable understanding of the world we all share.